Hi everyone, welcome back. Today we are solving smallest subtree with all the deepest nodes. So in this problem, we will be given the root of the binary tree, and we want to return the smallest subtree that contains all the deepest nodes in the original tree, and is considered the deepest if it has the largest depth possible among any node in the entire tree. So if we look at this example, we will return this subtree because it has the two deepest nodes, which is the node with values 7 and 4. And in this example, 1 itself is the deepest because it's the only node, so we return that node. And in this example, the deepest node will be at the node with value 2 because this would be the first level, this would be the next level, and this would be the final level. So we will return this node as the result since it has all the deepest node, which is itself. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we can use DFS or depth first search. So what we'll do is we will search down the tree using DFS, and when we get to the bottom or a node with no children, we will set that node's depth to 1, and as we move back up, for each node that we move up, we will add 1 to the depth. And on the way back up, not only do we want to figure out the depth of each node, we will also want to figure out which subtree has the deepest node. And how we can do that is each node that we move up, it will be a parent node of some children. So we will check if the left or right child of that parent has a greater depth, and we will return whichever node has the greater depth. Now, if the left and right child have equal depth, then we will just return the parent node, because if we think about it, let's say we have a parent and a left and right children. If these two are equal, that means the parent has all the deepest depth up to this point. If left is greater, then that means only the left node has the deepest depth up to this point, so we will just set it to left here. And if the right has the deeper node, then that means the right node has the deepest depth up to this point, so we'll just set it to the right node. And we will continue the recursion until we get all the way back up to the root node, and then we will return the subtree with the deepest node. So let's go over this example real quick. So first we will start at the top, look down, has a children with no nodes, so this will have a depth of 1, and since the left and right are equal, so we will set 6 to the node, come back up, look to its right children, look down, this will have a depth of 1 and 7, and then back up down here, this will be 1 and 4, and if we look here, the left and right have equal depth, so we will set the node to itself, and this will have a depth of 2 because we will add upon it. And now we come back up here, we see that the right node has a deeper depth, so we will set the node to 2, and the depth of here will be 3. Now we will look at its children, so come down to the left, this will be depth of 1 set to 0. Back here, now this will be 1, and this will be the node with value of 8. And now we come up, we see that these two are equal, so the depth is 2, and we will set the node to itself, which is the value with 1. And now we come up, we see that the left side has a deeper depth, so we would set this to 2, and the depth is 4, and we will return this as our result. And as you can see, this is where it has the subtree with all the deepest nodes. So the time complexity would be O of n, where n is the number of nodes in the tree because we have to look through n nodes, and the space complexity will also be O of n because the recursion stack can take up to n space. So now let's get to the coding part. So first we will write our DFS function, so DFS of node. If it does not have a value in the node, then we will return 0 and none. Otherwise, we will figure out the left depth and the left node. It would be DFS node.left. And the right depth and right node will be the DFS of node.right. Now to figure out what we should put for left or right, we will compare the depth. So if left depth is greater than right depth, then we will return the left depth plus 1 and the left node. Otherwise, if it's the opposite, then we will do the opposite. So I will go ahead and copy and paste and just convert whatever's left to right and whatever's right to left. So we'll change this to right, change this to left, and we will change what we return to right. Now otherwise, if they are equal, then you can add 1 to the left depth or the right depth, but I would just put the left depth even though you can do right, and we will return the node itself. And finally, we'll return DFS of root, and specifically the first index of what we get from the DFS function. Now let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.